Hey, hi everyone. Thank you for joining this Seldon deploy demonstration. I'm Tom Farrand. I'm one of our lead solutions engineers here at Seldon. I've been with the company and in the MLOps space for about 9-10 months now. And prior to that, I worked as a deep learning engineer at IBM. Really appreciate you taking the time out of your day to come and stop by. I think the session will probably be about 40 minutes, and then I'll leave some time for Q&A. So if any questions do pop into your mind as the session goes on, feel free to drop them in the chat, and I'll be sure to answer them before the end of the session. So we're first going to run through a little slide deck. It's 5 or so slides, and essentially it's just going to set the scene about what Seldon does and who we are, and talk a little bit about the technology that we're going to be working with today. So this is something that's probably familiar to all of you in the call, given that you're attending an MLOps based conference. So that is that machine learning can be transformative for businesses. So 63% of organizations are using machine learning for their critical tasks, and those that implement ML successfully are seeing higher profit margins, but also is sustained growth in terms of market share and revenue. However, there's this missing middle whereby only a small percentage of models are actually deployed into a production environment. This number varies from which source depending on the source that you're looking at, but it's never over 50% in all of the numbers that I've seen. And so clearly there's this issue in actually completing the last mile of data science, whereby you have a trained model artifact that you've created in your proof of concept or testing experimentation set environment, and you would now like to deploy that into a production world. And so this is really where Seldon steps in and helps you in that deployment, monitoring, management, and explainability of those machine learning deployments. So who are Seldon? We're a UK-based startup. We're founded in 2014, and we recently raised a $10 million Series A funding round. Our Seldon Core deployment solution is a massively popular open source library and has over 5 million installations. And we're trusted by some of the largest corporations in the world. So this is a mix of both open source and enterprise clients, but we're used in all of them across the board to power some of their most critical machine learning infrastructure. So getting into the nitty-gritty of really where Seldon looks to help you. This diagram is actually taken from a 2015 Google research paper that's now become pretty famous in the space. So I'm sure many of you recognize it. Unfortunately, Google left off the Seldon logo, but we've added it there for you. And what the paper said is that of all of a machine learning system's code base, only 5% of that code is actually machine learning code. And so there's a huge amount of focus and effort that's put into this area. And yet only a small minority of the overall code base is the algorithm itself. And so the remainder of that code base is actually made up of these complex and interdependent systems that help support the smooth running and operation of that machine learning code. And so on the left-hand side, in the gray, are your typical tasks and routines that are done by your data scientist or data engineer. So feature engineering, writing the algorithm itself for your data scientists, and then actually configuration and data collection and verification for your data engineers. Whereas on the right-hand side, highlighted in the teal, is really where Seldon looks to assist and help you. This is a far less, this area is far less defined in terms of roles within the company. And so it's all about this kind of notion of MLOps, so provisioning of serving infrastructure, monitoring those deployments, and setting up the right process and analysis tools to ensure that they're reliably and efficiently run. So these are the areas that Seldon looks to assist. And as we go through the demo, hopefully those become clearer and clearer around the value that we bring. So this is the Seldon stack of technology. I'm going to talk through it briefly, just so you have a concept and idea of where we fit and what sort of technologies we provide. The main thing to note is that we have 3 core projects of course, probably not the right word there, three main projects of deploy, core, and alibi. And we're going to start off in this middle band with Seldon core and KF serving. And so these are both open source technologies that extend the Kubernetes API, so they're custom resource definitions. And what they allow you to do is define Seldon deployments or inference services in the case of KF serving. And these essentially package your models up, deploy them onto Kubernetes infrastructure, and allow you to then serve requests through them. So just to distinguish between core and KF serving slightly, Seldon core is a technology that's maintained and produced by Seldon as a company, but we also contribute very, very heavily to KF serving, and we were one of the founding members of KF serving alongside Bloomberg, IBM, NVIDIA, and Google. And so we contribute code to both of these projects. KF serving is a serverless machine learning deployment service, so you can actually have your pods and deployments scale to 0 and then scale up as more requests come in. It also has some powerful capabilities around GPUs and serving multiple models from a single container or pod. On the flip side, Seldon core allows you to set up far more advanced deployment solutions and serving your model in far more complex ways. So this includes multi-arm bandits, ensembles of models, etc. Both, however, provide the same core functionality, and that is the ability to take trained machine learning models, containerize them, and deploy them out into a Kubernetes environment. So within core and KF serving, we provide a number of pre-packaged model servers. So these are essentially container images that we at Seldon have built and that can then be used to simply containerize a model artifact. So if we think of scikit-learn, you serialize your model artifact using DIL or joblib, and that can then be wrapped up and served via our container images. And so just as a pickle file. These prepackaged model servers extend from scikit-learn to XGBoost, TensorFlow, MLflow, PyTorch, Onyx, and I think that's all of them. And so they provide a wide range of frameworks which we support and kind of really easily work with out of the box. So it means that your time to deployment is hugely compressed, meaning that you have more time to spend on other things, such as different use cases or actually optimization of your algorithm. Obviously, we acknowledge that those 6 machine learning frameworks don't represent the entirety of the data science landscape, especially given how frequently it changes and updates. And therefore, that's why we have our custom language wrappers in the mix as well. So these allow you to, rather than containerize artifacts that you've trained yourself, you can actually containerize any arbitrary code. We provide source to image tooling, which means that even if you're not an expert in Kubernetes or infrastructure related technology, you can actually still containerize without having to write a Docker file. And what these custom language wrappers do is they allow you to write some boilerplate code, define your prediction method, define your metadata method, etc., and actually have those then automatically served on your behalf once you've containerized the image. We have custom language wrappers in a range of different programming languages. The first would be, and the most mature is Python, but we also have programming languages for custom wrappers for R, C++, Golang, Node.js, as well as Java. So quite a variety there, which will hopefully serve and make sure your use cases are up and running. So the next piece then is alibi. The next piece then is once those models are containerized and ready to deploy, core and KF serving allow you to define how you would like those to be served. So they can actually set up, multi-arm bandits, A/B tests, canary or shadow deployments. And this means that you have a lot of power in how you upgrade and roll out new models and control over how you test between different model versions. So it really is customizable and flexible to meet your needs. We then have Seldon Alibi, and Alibi is a set of Python libraries which implement state-of-the-art algorithms. So there are 2, Alibi Detect and Alibi Explain. Alibi Explain is focused on, as the name would suggest, interpretable machine learning And so it helps you to generate the why behind model responses. This means that you can actually start to generate deeper insights and meet compliance requirements around explaining of various responses that you give back to end users. We focus primarily on black box model explainers. And so what do we mean by this? We treat the algorithms themselves, so the models that you're deploying, a linear regressor, a convolutional neural network, as a black box. And we work solely with the inputs and the outputs in order to generate our explanations. So we tweak the input, observe how that changes the output, and from there we can generate things like counterfactuals, feature importance, etc. This means that our algorithms can support a massive range of different models and underlying machine learning algorithms, and that gives you a lot more flexibility in the use cases that in the areas and use cases that you deploy them out to. On the other side, we then have Alibi Detect, and this is focused on advanced machine learning monitoring. We provide multiple methods for doing both outlier and concept or data drift detection. So outlier detection, flagging in an unsupervised manner the anomalous data points that are being fed to your model. Whereas on the flip side, in the data or drift detection piece, this is actually showing how your data is changing over time when compared to a reference data set such as your training data set. So to contextualize that a little further, if you think about a model which uses height as one of its features to input, the height in different parts of the world is likely to be different on average. And therefore, if you train your model in one geography and then deploy it in another, there's likely to be drift in that feature because the distribution of heights in that geography is different to the one that you trained it originally. So these are the open source technologies that Seldon is a leader within. We then also have Seldon Deploy, which is our enterprise enterprise software platform. Deploy takes our best of breed open source capabilities in core KF serving and Alibi, integrates them within one another, and provides an API, SDK, and UI on top of that to ensure that you have a very smooth and seamless experience when using the tooling and platform. So one of the core tenets of Seldon Deploy is the self-service machine learning. So in a lot of organizations, we find that there's a wall between your data scientists and researchers and your software or DevOps engineers. And so the typical flow is that a data scientist will generate an absolutely fantastic new deployment, a brilliant new model, and then hand that over to the DevOps engineers in order to productionize that. This is problematic because they don't have a shared skill set. So your data scientists don't speak Kubernetes, whereas your DevOps engineers don't speak PyTorch, for example. And therefore, you have friction within this process. Seldon Deploy tries to help relieve that through self-service machine learning. And as we'll see, data scientists can actually take ownership and control of their model deployments, go through the UI or the API or the SDK, and actually generate all of these advanced components themselves and deploy them out into a production environment if that fits your needs. The next piece then is enterprise readiness. And so Seldon Deploy is hardened to support the scale of larger organizations, but also to support how your organization would like to consume the platform. So there's fine-grained role-based access control. There's also the ability to audit deployments, so to go back through how it's changed over time. So when was that explainer added? When was the canary added? And how did that change the deployment? And you can also roll back and restore those previous states. And so we'll see that in the platform in a second. The final piece then to mention before we dive in is the integrations. So the pre-built integrations provide a huge amount of functionality out of the box, and we'll touch on those as we go along. But it's important to note that we are a cloud native technology and we actually install into your infrastructure wherever that is running. So AWS, Azure, GCP, as well as on-premise and Red Hat OpenShift. We can support all of these different environments because Kubernetes is the underlying requirement we have. So what we can do now is shift gears and actually start looking at the tool. And so I'll just give that a refresh. And what we can start to do is to get involved and take a tour of the Seldon deploy platform. So you'll notice that along the top, we've got two tabs. We have our deployments and we have our model catalog. If we dive into our model catalog for a second, we can see we've got a huge number of different models that are already being created and deployed within this. If we click into one, we can see that within this model catalog, we can attach metadata, and some of it's populated automatically for us. And this means that others, once they've signed into the platform, can actually view previous models that have been deployed and update those and deploy them themselves without having to go through the task of creating that deployment all over again. So it adds a really nice element of reusability within the platform, as well as the ability to add that custom metadata that you personally or your organization cares about. If we go back to our deployments tab, we can see that within this namespace, so in the top right, we've got all of the namespaces within this cluster. So if we go to test, for example, we can see a huge number of others that have been deployed out, but we'll stick to dev for now. We can swap between these and actually limit who has access to which areas, so we can begin to partition up our production cluster. And you'll notice that all of these namespaces, apart from the Seldon default one, has this little Git branch icon. And so what this means is that all of our deployments are synced with Git, and this is what powers our ability to audit previous deployments. And so if we go to the corresponding Git repository that's associated with this deployment, and we go into the dev namespace and look at our Seldon deployments, we can see that we have this CFAR10 model. We also, as we'll see later on, that we've got a drift and outlier detector configured as well. So all of these elements are synced with Git and pushed every time a change is made, so that you have this really nice reproducibility aspect to your deployments. So what we'll do next is actually create a new model. We've got the ability here to create a new deployment. We'll call it MLOps test. We'll deploy it out into the dev namespace. And as mentioned previously, we have the option of using a Seldon core deployment or a KF serving inference service. In this case, we'll go with Seldon core. And then finally, we can choose between a number of different protocols as to how we want to send data to our model. And so we can choose between Seldon, TensorFlow, or KF serving. All are supported within the platform. Once we've done that, we can actually go and view our different predictors. So these are our the prepackaged runtimes that we have access to. So all we have to provide in this case is just a link to a model URI, which we'll do in a second. We also have the ability to generate a custom deployment. And so this just has to be a link to a Docker container that's actually been wrapped using our custom language wrappers. And you can find documentation about that on in the Seldon core docs, which we can link as a follow-up. In this case, we're just going to go for a scikit-learn deployment. We have one that's saved into a Google storage bucket, but any S3 compatible bucket works in this instance. And once we've done that, we can actually click next and go through the remainder of the wizard. Before we do that, it's worth noting that the remaining screens are all optional, and so they just provide additional configuration that we can work with. I'll talk through all of them just so you have a complete picture. But it's just good to understand that we could launch this deployment as is. And so it's really, really simple to get up and running and working with machine learning models in production using Seldon. We then have this predictor parameters page, and this is essentially where you can inject additional information into your model runtime. So you can set custom environment variables and also inject information directly into your Python code itself or Java code or whatever it may well be. This provides a lot of flexibility and reusability because you can make sure that, let's say you have a database key, you can make sure that that's not hard coded into your deployment, and therefore you can manage some more of your information security specs here. We can then set resource limits. So you can set the amount of CPU, GPU, and memory that you would like to be assigned to your deployment. And you can set that in terms of both how much you would like requested and also the upper bound that's going to be limited based on the cluster. We can then set up horizontal pod auto scaling. And so in this case, our model is going to scale up based on CPU utilization being at 10% on average. And then we can also add transformers. And so transformers are starting to delve into this more complex inference deployment. And so an input transformer is going to perform some pre-processing step and then feed its output directly to your model, whereas an output transformer is going to perform some sort of post-processing and take the input from your model and then return the output back to the user. These are just custom Docker images, and so you can run any arbitrary pre or post-processing steps that you have, and you can also, via the API, start to chain these together in much more complex ways rather than just having a single input transformer and a single output transformer. So there's a lot of customization that's available. The next piece we can do is add a nice arrogant version comment, which is going to be pushed out to Git and will also be viewable in our audit history. And then finally, we can see the fruits of our labor. And so we can see the deployment summary and all of the different components that are associated with it. So we can see the resources that we've requested. We can see that we've got this horizontal pod auto scaling set up, et cetera, et cetera. So we're going to go ahead and launch that. We can now see that it's syncing with Git. And if we actually go back to our repository, we should be able to see that we've now got this MLOps test piece that's just been added right now. That's going to start to create, and so we can dive into the model dashboard. We can see that our deployment's receiving 100% of our traffic, and while that begins to create, we could start to edit the metadata that's associated with this model. So we can see that we've got various different bits and pieces that have already been added. We can add things like the dataset version, or we could even add something like the author. And so we could say this has been authored by Bruce. So we can then save that metadata, and that will be automatically synced up with our model catalog. So we can now see that our deployment's available. What we'll first do, just to populate some of these graphs, is we'll kick off a load test. And so this is a really simple way of testing how our model is going to handle various inference requests. And this isn't something that a data scientist would typically have access to, just because it's usually a more specialized tool. But we make it very simple to kick those off and work with them. So we're just going to have one connection. We're going to run it for 5 minutes. And this is then going to just hopefully populate some of these graphs for us in this case. But obviously, in a more real world example, we'd want to use it to figure out what the memory or CPU utilization of our deployment is going to be before we place it into a production environment. So as that starts to pull through, we can actually go ahead and view the resources tab. This is one of the really important parts of the platform because it allows you to debug your deployment without actually going into the underlying Kubernetes infrastructure. This is really kind of calling back to that self-service workflow that we encourage and work with, and means that, you know, data scientists who don't have access to kubectl and can't view or work or interact with the underlying Kubernetes infrastructure, they can still get some insight into their deployment. And we're always looking to kind of improve this self-service workflow for everyone. So we can actually go in and view the underlying logs of our model. And so if we give this a second, it will hopefully pull through. And so we can see here that all our deployment's been doing is actually responding to this load test. If we now go back out, we can see that our horizontal pod auto scaling has also kicked in. And so we've now got 2 replicas of our deployment, and we can view the logs for both of them. If we go back to our overall dashboard, we can see that some of these graphs have started to populate. So we've serviced 10,000 requests almost. But we can also see that we've got approximately 64 requests per second. And we've got a breakdown of the latency that's associated with those. The next piece then is the CPU usage and the memory utilization. So we can see that our model is far more CPU hungry than it is memory hungry. And so we may want to tune our infrastructure accordingly. Okay. So once we've done that, we can actually start to think about, okay, I now want to roll out a new version of my model. How would I go about doing that without interrupting my existing service? So this is where these two panels come in. We can either add via the UI a canary or a shadow. If you are deploying via the API, you have a far greater number of deployment methods that you can use. But here we have the choice of a canary or a shadow. A shadow deployment is very simply, essentially, it's going to receive 100% of the traffic alongside your default predictor. So this is our default, our original one. So both will receive 100% of the traffic, except only the default predictor's answers will actually be pushed, responses will be pushed back to the end user. So the shadow is actually going to respond to the requests, but those aren't going to be sent back to the end user. They're simply going to be captured in our logging solution. And so you can go ahead and do a direct compare and contrast between your shadow's responses and your default's responses and determine which one is going to be more suitable in production. This is a really safe way of upgrading and rolling out new versions of models, because it means that there's going to be no change or no impact to the end user experience of your service. A slightly more aggressive strategy might be to deploy a canary. And so in this case, that's what we're going to go ahead and do. So we've trained a new XGBoost model on the same iris data set, and we're going to create a canary because of that. What we're going to do is split the traffic that comes into our endpoint. And so our canary is going to receive 20% of our model of the traffic that hits our endpoint. So 1 in 5 requests are going to be responded to our canary. And we can then use the logs as you would with the shadow to actually compare and understand which model's performing better, which one's performing within our latency SLA requirements, etc. So once again, we're going to click through this. You'll notice that all of the screens are the same as before. So setting your resources, your auto scaling, transformers, and adding a version comment. Something hopefully more creative than that. We can then launch this. And as that goes ahead, we'll see that automatically the traffic hitting our default predictor has been scaled back to 80%, and our new canary is down to 20%. So we can now see how this could help us roll out a new deployment without kind of exposing all of our user base to that new model when it's been untested and unverified. If we wanted to, we could immediately promote that. Saying our canary is great. And as we promote that, we can see that that automatically overwrites our previous and becomes the default predictor now. We can then go in and actually view all of the audit logs for this. So we can see, you know, the original deployment we had was created about 5 or 6 minutes ago. We can see all of the configuration that's associated with that. We can also see the comment that we've pushed to it. We can then see that the canary is created and the diff between those. And then finally, we can see that the canary is promoted. So the power of this is to see those changes, but also to act on them. And so if our canary, it turned out, wasn't handling things as we'd expect, we can go ahead and click restore state, and that will roll that back to a previous state of the original deployment with just the click of a button. So we can see this restoring deployment has now been committed. We can go back to our dashboard and we'll see that our scikit-learn model is back and is now spun up. We can see that all of the metadata that's been associated with that is still tagged and working. So it's a really, really easy way of rolling back and upgrading between those. The next couple of things to show off within this deployment, just before we swap over, is the batch jobs capability. And so all Seldon deployments are spun up as real-time endpoints. However, you also have the ability to send batch requests to them. So all you have to provide is where the input data is specified. That data should be in the format of the protocol that you're using. So, you know, just essentially just a list of the requests that you care about, and then where you would like the output of that model to be written to. The interesting thing here is that we support both predictions as well as feedback. And so just to expand a little bit more on this, every Seldon deployment opens up 4 API endpoints automatically for you. On a model level, you have predict, which responds to requests. You have metadata, which is where you can associate any arbitrary metadata you care about to your model within the code or as a YAML file. And so you can pull that, and that's exposed as a GET endpoint, so that users who have your who have that endpoint can actually call the get metadata method API endpoint, and actually receive example requests or authorship or the data types that the model expects. So it's a really easy way of associating those things together. The second to last one is doc, and that essentially is a Swagger spec of the other endpoints and just documenting those. And then you also have the feedback method. And what the feedback method allows you to do is to tag previous responses with the ground truth. And so you can actually say, hey, to your model, you got this request wrong. This is what that should have been. And from there, you can actually create both labeled training sets, but also you can use our metric server to monitor more data science specific metrics, such as accuracy, precision, recall, specificity, etc. So it's a really neat feature that we have. The other thing to note is that all Seldon deployments open up both REST as well as gRPC endpoints. And so you have that capability out of the box without any additional configuration. So that's the batch job functionality. And those REST and gRPC endpoints are available both as real-time or as batch. And then the final little screen for this deployment is just this usage monitor. So it gives you an understanding of how over time the usage of your containers is changing, or your CPU requests and limits, etc. We can actually spin this up into a wider usage monitor. And so we can look across this namespace within the dev namespace, but we can also view it from a all namespaces point of view. So you can see here we've got 45 or so average containers running. And so we're above the license threshold here of 30. So what we can do now is actually return to come to our CFAR 10 deployment. This is something that's slightly different. This is a ResNet trained using TensorFlow on the CFAR 10 dataset. So for those of you who may be unfamiliar, it's simply an image classification model. And so it's going to take in kind of generic sort of images of birds and lorries and cars and just tell you and classify what is in that image. You'll notice on the right-hand side, however, we've got these tiles which are now filled in. So we have an explainer associated with this deployment. We also have our advanced monitoring components of outlier and drift detector, and we could associate a metric server as well if we would like to, and actually use feedback to calculate accuracy and recall, etc. in real time. So to show off and take a look at our explainers, we can actually view all of our previous requests. So this is just going to go ahead and fetch them. And you can see here that we've been sending little images of lorries or trucks. There are 10 classes that the CFAR 10, that's where the 10 comes from in CFAR, associates. And class 9, you're going to have to trust me on this one, is that of a lorry or a truck. We can see here that our model's 99% confident that that is the case, that our lorry is running, that our image contains a lorry, which is useful because about 95% of this image is actually that of a lorry or a truck. But because we have this little magnifying glass, we can actually generate an explanation in an ad hoc manner. So we can go ahead and start to create an explanation. And so behind the scenes, what our algorithm is doing, our explainer is doing, is actually sending inputs to our model. It's chopping up our image and segmenting it, and then covering up different segments and observing how the output of our model changes as we cover up different segments of the image. And so you can see that kind of more intuitively here. So if we look at the bottom area down here where we've got examples which our explainer sent to our model, you can see how the explainer has actually chunked the image up into different segments and used those to determine the segments which are of most importance. So in this example, segment 0, which is this kind of windscreen area, is contributing the most in terms of precision, about 3/4 in towards the threshold judgment to make this model classify our image as a lorry. And then the remaining 25% is actually coming from this wheelbase area. And so this is a really easy way of actually understanding more in depth about how your model's performing and gleaning deeper insights into that. The explainability methods we have, within the UI, we have integrated dashboarding for the anchors method, which is kind of an improvement on Lime for those that may be familiar with that algorithm. And we support text, tabular, and image data. So we have a wide variety of modalities that we can support and work with. We can then drop into the monitor tab, and we can see that within this period of time, we've got no outlier requests found. I hope if I go back in time that we can find some. So this would actually just show us a view of clickable points, which are inliers and outliers, and show us the difference between them. And we've also got drift detection set up and running. And so this would actually flag as requests come in where the drift is occurring. And so we could act on that. So we could set up things like alerts, which could then trigger a retraining pipeline and actually get us to understand a little bit further around why our models, and retrain the deployment so that that drift is no longer effective using the new data set that we can collect. So that's the majority of what I wanted to take you through today. The other piece to mention is, and I've hammered this on a little bit, but we do also have a fully fledged API as well as an SDK that allow you to do all of the actions and more that you've seen within the UI via REST or Python. And so you can look at the GitOps status. You can generate load tests, create and delete outlier detectors and drift detectors, and actually view the underlying Kubernetes resources that are associated with your deployments. So there's a huge amount of capability and functionality within the tool. And that is pretty much all I would have wanted to show off. So we've kind of ran through that in 40 minutes or so. I really appreciate everyone taking the time. I'm happy to now answer some questions. So I can see that Shashank has asked a couple in the chat. So the first one is an overview comparing Seldon to other serving-focused tools. This is a great question, one that I could spend a huge amount of time talking about. So I guess it depends which tools you're thinking of specifically. We find that Seldon as a best-of-breed platform for MLOps, specifically focused on this last mile of data science. So the deployment, monitoring, management, and explainability of machine learning endpoints is far more in depth and much broader and production ready than most other competitors. So if we think of a tool like Bento ML, that does provide very simplistic serving capabilities, but there's no kind of monitoring that's associated with that. There's no way to manage those at scale if you have tens or hundreds of deployments. And so while it does the deployment piece very, very well, there's the wider serving picture is broader than that. If we think to larger competitors, some of the cloud players, a lot of those have kind of confusing and multifaceted ways of deploying algorithms that aren't always clear. They provide a lot of kind of features, but those aren't the experience of using those isn't seamless and isn't particularly friendly. And in addition to this, we have far deeper capabilities around explainability and the monitoring side of things that we excel at. So feel free to follow up, Shashank, with more kind of detailed questions if that doesn't cover it, but hopefully that gives you a little flavor of where we fit in. The second one was for shadow deployment. Does Seldon offer a way to potentially funnel the shadow results into the data ingestion and model training pipeline in order to do a full end-to-end A/B test of the ML pipeline? So that is absolutely that functionality would absolutely be possible. We don't provide that kind of out of the box as a simple API that you can just drop in. But you could absolutely leverage, we make use of Elasticsearch or the Elk stack under the covers. And so you could work with Elk and actually pull everything out. We tag any response that's been made via the shadow as metadata. So you could simply search on that, on the deployment you care about, in the time frame you care about, and just extract all of the data from that. So that would be pretty straightforward to set up. Haber has asked, how do you calculate data drift? Which is a great question. So that genuinely depends on the algorithm that you go ahead and select. So if we look at the Alibi Detect documentation and have a view of the different algorithms within there, you can see we've got a whole load for outlier detection, but we also have a whole load for drift detection. So the drift detection is dependent on the algorithm that you go ahead and use. I believe that the one that's used for the CFAR 10 example is Kolmogorov-Smirnov, in which case it's a statistical KS test. And I'm not going to even try to explain the kind of stats and maths behind it, just because I would honestly be way out of my depth. But the documentation is incredibly detailed and will help you get up and running very, very quickly if that is something you want to do. So we can definitely follow up. I'll pop that in the chat. So that's Alibi Detect. And the same then is true for Alibi Explain. There's a wide range of different algorithms that are available. And you can make use of many of them within the platform. So I've just dropped those within the chat as well. So I guess at this point, are there any further questions or areas that people wanted to touch on? There's a question in the Q&A tab. I have replied to it, but I can reply live. Oh, there's another one. So Luri has asked, can Seldon products create pipelines to automate end-to-end life cycle of machine learning in the Seldon product? And so we can help in the creation of those pipelines. So we, as mentioned, the API, the SDK hooks mean that you can actually just write kind of templates and configurable systems within that are reusable and reproducible. And then that can be orchestrated by a tool such as Jenkins. The second couple of questions that have been asked are around KF serving is still beta version. Can we use that for production deployments? I think that's a question best answered by your organization's appetite for risk. Obviously, beta technologies are less tested. Seldon Core is definitely production ready, and we have there are I believe a huge number of models. Someone told me recently nearly 1 million models running on Seldon Core, and so that's definitely battle hardened. But again, that will come down to your organization's appetite for risk around KF serving in its beta status. Can we use Kubeflow pipelines for triggering pipelines to retrain models and deploy with Seldon Deploy? You absolutely can. And in fact, we have a demo that demonstrates just that. And so we can see here if in this example that we build out a Kubeflow pipeline and then interact with the APIs to actually trigger those actions and creation within the Seldon Deploy interface. So that is absolutely possible as well. So hopefully you enjoyed the session. That's all I had for you today. Again, really appreciate you taking the time to join and listen in. I hope you enjoy the rest of the MLOps demo days, and please reach out to the Seldon team. My email is tom@seldon.io. So if you have any further questions, I'm sure we'll be able to follow up and discuss. So thanks again. Really appreciate it.